So, welcome everyone. Today I will be talking a little bit about Rust. So, first of all, my name is Ryan. I'm based at the Pretoria office. The tech stack that I work with BBD is Python and C Sharp. But I'm sure if any of you have a look at my GitHub, you will find it filled to the brim with Rust. So, why did I pick Rust? There's a lot of reasons, and during this talk, I will hopefully be able to share some of my experiences with Rust and maybe convince one of two of you to maybe decide to use Rust in your next project. So, when I say Rust, what do I actually mean? I mean, I could give you the dictionary definition, but I don't feel like that's really my style. So, what am I actually going to talk about today? So I'm going to talk a little bit about errors, where we can use Rust, and also some of the cost benefits from using Rust. So let's talk a little bit about safety in Rust. Now, I'm not going to go into memory safety and how Rust achieves this without a garbage collector. Rather, I'm going to talk about how the compiler forces you to make better decisions and it prevents errors in that manner. So I'm sure we've all spent hours and hours trawling through logs just to find an error like one of these. Luckily, Rust has the solution for us. So let's have a look at a quick example where I'll show you some Python code and we'll kind of discuss a little bit. So I'm sure we've all had to do this at some stage. We make an API call, we get some data back, we do a little bit of processing on it, and we get something useful from it. So this code works, right? Oof, it's 4 o'clock in the morning, 15 missed calls from the boss, production is down, looks like I'm going to have to brush up on my CV. Well, let's rewind a little bit and dissect some of the issues with this code. So the main issue is that we made some unsafe assumptions. So let's have a look at those. First of all, we're assuming that when we make this request to the server, that we're getting something back and that it's not an error or something. Second of all, that the structure of this actual object hasn't changed. So it would have a card and that card would have a balance. Lastly, we'd make sure that we could actually convert this balance into a float or something. So let's have a look at a bit of a Rust conversion. Now, this is a pretty bad conversion. I mean, it still does the job, but it will crash just as hard as that Python one. We can note this with all the unwraps we're using. So if we want our code to never crash, we have to find alternatives to these unwraps. So let's have a look at that. Now, this is a very verbose example, and quite honestly, it's difficult to understand, difficult to read, and quite honestly, not something that I'd want to deal with. So what would a better conversion look like? So in this conversion, we can see we've cut our code basically back to the original Python example. We can stay on our happy path by using the question mark or try operator, and this propagates our errors upwards, meaning our calling function can handle them. So moving on, where can we use Rust? Well, everywhere, of course. From bare metal chips to back-end code, AWS Lambdas, front-end, mobile, and even native app development. Let's have a look at some packages that can help us through this journey. So I won't go through all of them, but obviously these are just a couple of examples. Things to take note of with SQL using SQLX. We'll talk about it a bit later some more, but it provides support for 4 databases, one package. That's pretty cool. For graphics and WebGPU, it acts as a lightweight wrapper around a couple of these other more well-defined graphics APIs. This means that we can write something once and basically compile it down to a bunch of different architectures. So furthermore, we can have a look at where we'd use this in the real world. So I mean, having a look, all our cloud providers give first-class support. Rust has become the third language to be supported and accepted in the Linux kernel, the other two being assembly and C. Not even C++ was allowed. Finally, in Windows, a lot of the security critical processes are being rewritten in Rust. So I guess the meme of rewrite it in Rust has come to actuality. So why would we want to use Rust? I mean, we've already had a look at where it's used and a little bit about the error handling, but how for us developers does it help? So to start off with, it has a similar C-like syntax, meaning if you're coming from Java, Go, or JavaScript, it will be very easy to pick up. Heck, I think even Python people will be able to understand this. Second of all, it allows for expressive thinking. So what exactly is expressive thinking? Well, essentially, it allows us to reduce mutability, and it actually gives our semicolons a meaning. So here we go. We see in the first example, we just have everything as a statement. In the second example, we remove assigning that actual output to the front and then basically allow our if statement to essentially return something. And that's how we assign the output. Another awesome thing is that there's no trade-off between ergonomics and speed. In this example, we have a zero cost iterator. So what does zero cost actually mean? Well, it would be more a zero cost abstraction if we really went down to it. But essentially, this means that we can have all cool things like type generics, all awesome things like that. And in the end, they just get compiled down to a couple of loops, and there would be no additional overhead for allowing all these features. Another cool thing, nulls are no more. We only have optionals. Why are optionals cool? Well, we can use all the iterator methods on optionals, meaning we can do a map like in this example. Now, another thing that is more a design thing, but allows Rust kind of builds into this is how we make invalid states impossible using an enum. So in this example, we can't make a dog with a random breed or a random condition. They have to be ones that we've defined previously. We could go more into this about how enums can actually hold state, but I'm not going to. Let's have a look at one of the superpowers of Rust, and that is its macro system. So you might be looking at this code and thinking, that's HTML. Okay, cool. But I would tell you, no, that's actually Rust. We have built a complex macro that allows us to compile time check this HTML, meaning if we made a mistake in it, we would know about it. Another cool thing is syntax highlighting would also be introduced via our macro. Now, you might be saying, well, that's pretty cool, but HTML is pretty basic. Let's have a look at SQL. We have compile time evaluation with the SQLX crate. So what does this actually mean? Well, essentially, whilst we compile our program, we make sure, oh, we have this table, and yes, it has these fields. Now, how does it do this without completely messing up our database? Well, it puts everything into a transaction and then rolls it back. You can also create local copies to do this as well. So let's talk a little about performance, portability, and profit. So we all know time is money, but that shouldn't be the only metric we measure by. Here I have a table that shows the energy consumption as well as the time it ran for a specific program to run. Now we could kind of see that C is the best, but I don't think we're ever going to get any quicker than that. We see luckily that Rust comes in close second. All other languages can't even compare. So let's have a look at a little bit more of a shortened down list here. We can see Python comes dead last at 70 times. So that means if it took 1 second to run our Rust program, it would take 70 seconds to run Python. Now, I know that metrics can sometimes be misleading, but it just gives you a decent kind of idea of why this could be potentially an issue. Another awesome thing, Rust can build to many architectures. So this kind of negates the whole idea of having a separate kind of a runtime in order to allow write once, run anywhere kind of a thing. Another awesome thing is that if we have a look at AWS Lambdas, if we build to the ARM architecture, we're going to save an absolute heckload. So in summary, we can see that Rust is not only faster, allows for ergonomic code, proper error handling, it's cheaper and more energy efficient. But I mean, in the end, it's your choice to decide what you want to write your code in. And that leaves me to this. If you're sold and you decide you want to start writing Rust, here's a couple of resources that you could use. So I want to end off by asking if there's any questions, and you can access my slides and the markdown with all the notes I had here.